that's well beyond the scope of the course, but just in case you've heard of Higgs, it was the theorists trying to come up with explanations for, well, any theorist thing is you come up with rules and then someone goes, well, why is that true? And so they dig down deeper and yeah, there's anything that's not unallowed, they're going to make it up. All right, questions to hear? All right, I think at this point I'm officially going to say I'm done with chapter 2. So, because of that, let's talk about quiz dates. So if you'll notice, in chapter 2, if you don't have the book, then you'll look at it later. There's a think and solve, think and rank, think and explain, and think and discuss. Some chapters will have a 5th section called plug and chug. Now, if on Blackboard, if you go to assignments under chapter 2, there's 2 documents there for chapter 2. The first document is just problems from the textbook listed. These are the ones that I suggest you look at. The second document is the same thing except it has the solutions. So I'm not going to collect the homework. This is for you to help you study. What I'm going to do of the assigned problems, I'm going to take one of the think and solves that I've assigned to you, one of the think and ranks, one of the think and explains, and one of the think and discuss, and that will be the quiz. Potentially, you have no idea which ones I'm going to pick, although some students start playing the game at some point of trying to guess which ones I'm going to pick. Sure, why not? So, because you have the questions already, you have this many questions, and I'm picking this many, and you have solutions. In theory, you should know all the answers before you walk in. If you try to memorize your way, from what I have seen in the past, if you are huge into memorizing, that will work in the short term, but at some point, that is not a good strategy. Please don't try to memorize. I had once, this was with a 251 course. The student had memorized exactly the book solution. Now I changed the numbers, because anything with numbers in it, I feel free to change. You should still be able to do it. The person wrote down the exact solution, and this wasn't a simple one, wrote down the exact solution to the given the numbers in the book, not the problem numbers on the quiz itself. So that's probably the most extreme case of they had it memorized so well that they had no idea what the question was asking.
So all of those are ones we should do because some of them are going to be on the quiz.
Yes,
Okay.
yes. There is no question on the quiz where I cannot point to, hey, here's the problem it comes from, and you can see right here, it was assigned. If you like surprises, you can come in completely unprepared. Also, not a general recommendation. And I like to, in general, have one class in between when I'm officially done with the chapter and when the quiz is. And so that puts us Wednesday, the yep. Is that October? There's September. 9 to quiz. Homework quiz on chapter 2. Oh, we should put.
Oh, it's just chapter 2.
So next Monday would come in, I'll start out with any questions. And then if you have questions about the problems, that would be a good time to ask. The day of the quiz, I'll often start out with any questions. The difference is on Monday, since we're not having the quiz on Monday, but Wednesday. On Monday, I'll take however much time I need in order to answer your questions. Wednesday, I might cut it off at some point and say, listen, we got to get the quiz done. So also, if you notice the two documents there, there's also some links just below it in Blackboard for chapter 2, and that's where I talk through every single one of these. Most of the time, I believe students don't really look at those, but last fall, I had a set of students who basically thrived on those. And so I think at this point I have that thing for every chapter where we have questions, where there are homework assignments, at least up until we get to electricity. So that's another resource available to you. All right. Any questions before we start talking about motion? I would like someone in as much detail as possible describe to me how to get to the bathroom from here. Does anyone know where the bathrooms are? Oh, they're on the other side of this wall. If you come up the steps and instead of taking a right to come to here, if you took a left, about halfway down the hallway. That's where the bathrooms are. Ladies' room, men's room. Or tell me how to give me explicit instructions about how to get to the stairs.
You walk over, open the door, walk out.
Walk over, open the door. How do I get there?
Take the straightest path from where you're standing and walk. And then open the door.
The straightest path.
The straightest path to the door from where you're standing.
So you want me to go to my right?
Yes.
Okay.
And then open the door.
How far do I go to my right?
However many feet it is.
Just give me a number.
Like 20.
All right, so 20 feet to my right.
Yeah.
Open the door.
Open the door. Then turn to the right. Walk another 25, 30 feet.
I will contend that's impossible. All right, so walking, let's say it's 20 feet. I open the door and then turn right and walk 20 feet. That's what I got. Did I miss something?
Walk out the door.
How far?
3 feet.
All right, 3 feet, 5 feet. We'll split it 4 feet. So I walk out 4 feet and then what?
Turn right.
Okay, and then
Walk straight until you get to the door and turn.
how
left.
far? What-
25 feet.
All right, so 25 feet. So then I turn right, take 25 feet.
Turn left.
Okay.
Open 10 feet. Open the.
All right, so as you're giving me instructions, as I was trying to get you to do and give me detail, there are two things involved. How far and in what direction? Hey, vectors. Matter of fact, in some classes, I make it even more excruciating. I'm starting here, what do I need to do to get there? Well, because if I turn this way, there is one thing I have to do in order to get to the door. Sorry, I'm not hearing the.
Walk.
Yeah, but in terms of describing the motion, I have to speed up because I'm at rest right now. Now, when we are trying to describe motion in physics, there are certain things certain key terms. There are 4 major ones that we will deal with in more detail than you dreamed even possible. Position, displacement, velocity, and acceleration. These are key terms when talking about motion. Matter of fact, these are all vector terms. If I ask what is the displacement, that is a vector I am asking about, so magnitude and direction are both required. Velocity is a vector quantity. If I ask what is an object's velocity, I'm asking for how fast is it going and in what direction. There are scalar analogs for these. For most of them at least. Displacement, the scalar analog is distance. So if I'm asking what is the distance traveled, I'm not asking a vector question, I'm asking a scalar question. The scalar analog of velocity is speed. And then fortunately, the scalar analog of acceleration is acceleration. But at least with speed and distance, automatically, just based upon the word I use, you immediately think scalar. The other two, displacement, velocity, position, these are all automatically vector. And I will talk about how I differentiate between the accelerations, say on a quiz or test, when I ask what's the acceleration, how do you know which one I'm asking about? Of course, physicists don't like writing these words down, so we use symbols. Position has several symbols. I use X a great deal. Some textbooks will use X, Y, or Z to represent, horizontal, vertical, and depth. I tend to use X for whatever. S is used as a generic term, and the other most common one used is R. R comes from radial. So generally, if you have some central point and you're talking about moving away or towards a central point, that's when you tend to use R. S comes from the Latin, stadia, which was basically the ancient Roman mile, or their equivalent of that kind of distance. And then X, Y, and Z come from the brainwashing from the math people. Position is where an object is with respect to, that's WRT, with respect to the origin. And in parentheses, I'll put down 0. If I have a number line, and a number line has a 0 on it, we generally don't call that the origin, we call it 0. But once you get axes, you have the origin, that's where they meet. So if I have, let's say, a coordinate system like this, and I have an object sitting right here, that would be the position, and also x sub I. The little subscript I here means the initial position. So I have an object that's sitting right there at some initial position. Questions to here? There is no scalar analog of that. I played around with location at one point, but that didn't feel right. Displacement is can be defined one of two ways. It's either the change in position, or it is where an object is with respect to the starting point. Because it is change in position, we use the shorthand notation for change. And what is the shorthand notation for change? Otherwise known as delta, capital delta. So displacement is delta x or delta y, or delta in front of whatever you're using for position. So if I start in this location and then I end up here, that is my final position. My displacement is from where I started to where I ended. That is my displacement right there. Displacement in purple, based on my initial position and final position. Velocity change in position over change in time. Or how fast an object moves. And in what direction. And the symbol, as I've used in class already, is V with a vector symbol over it. And acceleration change in velocity over change in time, or sometimes referred to as the time rate of change of velocity. In other words, at what rate is the velocity changing? And the symbol, at least the symbol's easy, A with a vector symbol over it. Questions to hear? All right. Let's talk about the scalars for a moment. Distance is just how far an object has moved. It's not relative to anything, it's just how far an object's moved. The symbol, though, is basically, the symbols for these three are basically this without the vector symbols. So, delta x, delta y, just no vector symbol over it. Speed is just v, it is not s, it's v. And acceleration is just a. Speed is change in distance over change in time, or distance over time, sorry. It's distance over time. Acceleration, scalar acceleration is change in speed over change in time. So let's illustrate some of the differences between them. They start in Columbia, South Carolina. And Winston-Salem, we'll just simplify it, is 200 miles north. Close enough for what I want to do. So 30 years ago, I lived in Columbia, South Carolina, and now I'm in Winston-Salem. If I consider this my starting point, what is my displacement over the past 30 years? Keep going.
North.
Yes, direction matters. So my displacement for my last 30 years of life, my displacement is 200 miles north. Doesn't seem like particularly much. However, the distance I've traveled, I did consulting for a number of years. I was driving at least 1,000 miles a week. But let's say we're driving it and you check your car's odometer at this point, and then you start driving, you decide to take the leisurely route and you're going around visiting small towns. And the change in the odometer on the car is 500 miles. What is the distance traveled? Was not expecting the silence on that one. No, not two. You said 200?
200.
No. There's only one other number up there. Yeah, 500 is the distance traveled.
Oh, distance.
Oh, sorry,
Okay, so.
distance. So recognize that when we're talking about displacement, it really cares about where do I end up relative to where I started. It doesn't matter how I got there, doesn't care about the in-between, it just cares about where am I relative to the starting point. Distance cares about all the little things in between. And this brings up a particular awkward notation. Often, if I'm talking about force is a vector. I put the little symbol over it so you all know, we're talking about a vector force. If I want to talk about the magnitude of force, so if all I care about is just the magnitude, I can symbolize that, if you flash back into your notes, as an absolute value sign around it. But oftentimes, we can just write F without just drop the vector symbol when I'm talking about the magnitude. But recognize that doesn't necessarily work here, because if I just drop the vector symbol to indicate the magnitude of the displacement, I'm not getting the distance. The magnitude of the displacement is 200 miles. The distance is still 500 miles. So when I'm talking about magnitude, usually in a quiz or test, I will say, what is the magnitude or the size? And I will try to use the absolute values symbol notation of it instead of just the letter without the vector symbol over it. There are many cases where you can get away with this, but there are other cases where you cannot get away with just dropping the vector symbol to represent the magnitude. Velocity versus speed. I'm now going to race Usain Bolt around the track. I'm assuming Usain Bolt is still the fastest man alive. Or ever, actually. So Usain Bolt and me. I'm going to contend that I am faster than Usain Bolt. But only if you look at it the right way. So we start out, gun fires, Usain Bolt goes all the way around the track in 40 seconds. I go all the way around the track in 200 seconds. Well, let's figure out our average velocities. Velocity is change in position over change in time. Technically, that is the average velocity. The average velocity is the change in position over the change in time. So when Usain Bolt starts out at the starting point, goes all the way around, ends up back at the starting point, what is his displacement? In 40 seconds. So it's 0 meters in 40 seconds. So Usain Bolt's average velocity is 0 meters per second. I go all the way around the track, end up back where I started. What is my displacement?
0.
So my average velocity is 0 meters over 200 seconds. So it looks like I'm just as fast as he is. Now, instead of looking at it that way, when he finishes, I'm probably somewhere around here. Who has a greater displacement? Because his is 0. Mine's not 0. Which means my average velocity at that point is greater than his. I am faster than Usain Bolt. The first one, we both got nowhere. He just did it in less time. But I prefer to think of it the other way. Now, I'm not talking about speed, and I'm not talking about instantaneous velocity. So let us bring in some extra vocab here. When talking about velocity, there's actually instantaneous, and then there's average. If I just say, what is the velocity? Instantaneous is default. If I want average velocity, I need to specify. Same with acceleration. There's instantaneous, and then there's average. If I just say, what is the acceleration? That is instantaneous by default. If I want the average acceleration, I need to specify average acceleration. Now, a lot of the times we'll deal with constant acceleration, so instantaneous and average will be the same, but not necessarily every time. And then displacement, there's instantaneous, and then there's overall. Unlike the other two, if I ask what is the displacement, overall is the default. So right here, when it got to the end point, I asked what is the displacement. I was asking the overall displacement. I'm not talking about the displacement from a moment earlier. So what really is the starting point? If you were doing your own displacement, would you do it based upon where you woke up this morning or where you were born? Assuming you didn't wake up where you were born. Now, acceleration, we got the same word, and I've gotten much better about this. Occasionally I do forget. If I want the vector acceleration, then after the acceleration, I'll put that symbol with symbol. If I want the scalar acceleration, then I'll put just the letter A after it. So I will specify, what is the acceleration, comma, and then either that A or that A with a vector symbol. So you know which one it is. If you're on a test or quiz and I use acceleration but forget to do that, just ask. But as a general rule, the vector one is, usually it's the vector one that's being asked. Questions up to here? Now we talked about before, if something's traveling in a straight line, I think we've talked about this before. It's something, if you're dealing with one-dimensional motion, you can get away with indicating direction with just a plus minus or 0. If you're 2 dimensions, you have to use I hat, J hat, but here in one-dimensional motion, you can get away with plus minus or 0. So the sign, plus, minus, or 0. Position is positive if on plus positive side of 0, or origin. So I'm now about to walk back and forth in front of the board, and so I'm just going to arbitrarily make that my origin. Right there. And I'm going to make to the right positive. Therefore, right now, is my position positive, negative, or 0? Yes, why?
Because you're on that side of 0.
Right. There's 0 over there, I'm on the plus side. Now, as I'm doing this, we're going to go through several of these. I don't want to get into parallax issue because Matthew and Joanna probably have the most extreme views. If I'm standing here about at the origin, I'm supposed to be at 0, even though it looks to you, Mike, I might be on the plus side, and it looks to you, Mike, I might be on the minus side. But if I'm around 0, I'm at 0. So, what's my position now? Wow, so quiet. We could do that in unison, I bet. What's my position now? Some of the voices were so in sync, it did not sound like more than one voice. What's my position now? We're going to be doing more of these. Chime in. Since I can't see your mouths moving, I can't necessarily identify who's actually saying wrong answers, so go for it. Displacement, overall displacement, is positive if on positive side of starting point. So for the sake of this exercise, I'm going to make that my starting point. Now, positive direction is to the right. That I identified it once. I don't have to identify it again. So, give people a chance to write down. Maybe that's what threw people last time. Get rid of some of the clutter. All right, so here we go. Get ready. My position, positive, negative, or 0?
0.
My position, positive. Position cares about that. My displacement,
0.
there we go. My position, my displacement, my position. Everyone can play. It's not just a few people. My displacement. All right. My position. Displacement.